All right, so let's look at a very simple example of how do you use the make utility with a single C++ file. All right, so we have a hello.cpp file, which all it does is just print something to the terminal. And so before we use the make utility, let's first look at how we would create this an executable from this hello.cpp source file. So you have a source file. What you would do is you would there are two steps to get the final executable. So from the source file, you would first do a compile to get an object file, and then from the object file, you would do what's called as linking to get the final executable. All right. So for doing the compile, what you would do is you would use G++, and then you specify the C++ standard. We will be using C++ 17 throughout this course, so let's specify that. And then you have the C flag, which specifies that we want to get an object file from the source file. Okay, so we specify the source file. Now, if you run this, if we do an ls, which gives you the different files here, we see that the object file has been created. So this is the compilation step. Now the second step is the linking step. So we want to again specify the C++ standard, and then we want to say that uh, the -o flag actually gives specifies what's the name of the executable that you want. So let's just call this as hello, but this could be any name. Um, and then we have to specify which object files have to be used to create the executable. So in this case, we only have one single object file from which we are creating the executable, which is hello.o. And so once we do that, if we do an ls, we have the executable here. Now we can run the executable like so, and it prints and it works as expected. All right. Um, so this is how you would do these two steps to create the executable. Now let's use a make file to have the make utility do this for us. All right. So before I begin, let's first remove the object file and the executable. So we only have the source file here. Now let's create a make file. Um, so a make file is just called make file. And so so when you are creating any sort of a make file, what you need to think of is what are the dependencies that I have. Okay, so you have um, so let me write this down here. So what are the dependencies um, uh, that um, that I have for the final executable? Okay, so if you think about this, um, you have um, the final executable, which is dependent on the object file. So if you look at how we created hello or the final executable, we were using hello.o as the object file to create that, right? So that means the final executable is dependent on the object file. So we have hello.o, which is our object file. Um, and then now what does the hello.o object file depend on? So if we look at the command that we used the hello.cpp to generate or create hello.o, right? So hello.o is dependent on hello.cpp. And so this is the source file. Now in the lab instructions, you might see that the arrows are switched. Um, it doesn't really matter as long as you understand the concept, like if that this depends on this and this depends on that. That's all that matters here. All right. Okay, so that's the first step. When you create a makefile, you have to think about like, how do I get the final executable? What are the dependencies? All right. Now to review how a makefile looks like, a makefile has a set. It contains a set of rules, and the rules are in this format. You have a target, which depends on some prerequisites, and then you have what's called as a recipe to create the target from the prerequisites. So we've reviewed this before, and so um, you know this already. Now, how do we create these rules for this specific makefile? So let's look at that. Um, so let's take the first dependency. So what was the first dependency? So our first dependency was um, that this executable is dependent on the object file, right? Now let's think of um, what's the recipe to make hello if you have hello.o. Okay. Now we've already seen that here. If you have hello.o, this is the command that you run to create the executable hello, right? So that is the recipe for this. Okay. Now so we have this. Let's write this in the syntax of make. So the target here is hello. So that's the executable we want to generate. And this is dependent on hello.o. So we only have one prerequisite here. And what's our recipe? So if we have hello.o, we have this line to generate the hello executable. Does this make sense? Okay, so this is the first dependency. Now we also have to specify the second dependency, which is this one. So excuse me. If you have an the hello.o object, oh sorry, if you have the hello.cpp source file, how do you create the hello.o object file from it? We've also seen that. So this is how, if you have the hello.cpp file, this is how you generate hello.o from that, right? Okay, so let's make this into the make syntax. So hello.o is the target here. And what's the prerequisite? It's dependent on hello.cpp. Um, and what's our recipe? Our recipe is this. All right. Okay. I think I forgot to mention that whatever begins with a pound sign is a comment. So the make utility would just ignore those. All right. So we have the make file here, right? All right. So I've saved this. Now let's come back to the terminal, and then let's do an ls here. Um, so what do we want to do from here? So we want to first create hello.o. And so if you want to create a specific target, which is listed in the make file, what you would do as a command is you'd specify make, and then you specify the name of the target. All right. So here, let's create um, this target first. All right. So we would do hello.o, right? So now if you look at that, um, it actually ran the recipe for hello.o, right? And if you do an ls, you see that hello.o has been created. Now let's do the make for the next target, which is the executable. So if you do make hello, it ran this recipe And if you do an ls, you can actually see the hello executable here, and you can actually run the executable and get the same result as if we had manually compiled and linked those files. All right. Um, Now, instead of doing this as two steps, using make, what we could also do is we could directly make this target, and then the make utility would look at all of the dependencies, the entire dependency chain, and then it would run the recipes for all of those to get you the final hello executable. So you don't have to like do make for every single target, all right? So let's try that. So um, let's first remove the object file and the executable. All right. So we only have the source file. Now let's do make hello directly. And now you see that all of the recipes which are required to create the final executable is being done or executed by the make utility. All right. Um, so I want to like I want to walk you through how make runs like or how does make actually go through this flow. So if you ask make to create the hello target, how does it actually work? So if you say make hello, um, the make utility would look at the make file and try to see if there's a target called as hello. It finds that there is a target called as hello, and then it looks at, okay, so let's um, yeah, let me just remove these files again so that it becomes a little more clearer for you. So, um, so yeah, so there's only the C++ file and the make file right now. Okay, so now if you call make hello, what happens is um, it'll check, it'll come here, and then it'll look in the current working directory if there is a file called hello.o. Is is there a hello.o file here? There is no hello.o file here. So then what the make utility does is it will now look for, I don't seem to have hello.o here. Is there a target for how to create hello.o? And then it looks throughout the make file, it finds this target, and now it checks, okay, well, what are the prerequisites for hello.o? And now it sees that, okay, hello.cpp is what is required to create hello.o. And now it checks in the working directory, is hello.cpp here? It is here, right? Now, since that is here, it would run this first, and then it'll, uh, it'll run this first, and then now it'll have a hello.o file, right? Now it'll come back here. Now it has all of the prerequisites which are required to create hello, right? Now it'll run this recipe. So if we do make hello, it actually runs 2G++. So the first command that it ran was actually this one because it needed to generate hello.o first. And then once it has that, it runs this line, which is here, and that is used to generate hello as the executable. All right. Does this make sense? Awesome. Okay. Um, so the next, um, I want to talk about a couple more things here. So the first thing is um, I'm trying to think about like what ordering I want to teach these things. So okay, so let's talk about variables first. Okay, so make variables. Um, So there are cases in which you need to configure your make file, and then you need to like quickly change things around. So the compiler that we used in this example was a G++ compiler, but you could also be using a different compiler like a clang++ or something like that. So um, you could specify a variable which is called so CXX. It could be anything. I'm just calling it a CXX. And now we have it set to G++. All right. So we could then change this. And how do I use a variable? To use a variable, you could do dollar curly braces and then you specify the name of the variable. So I would change this and I would change it here as well. All right. So that's how you use a variable. Now, if in future you find that okay, you want to use clang++ as the compiler instead of G++, you don't have to like manually go to every single recipe and then change that. Instead, what you could do is you could just comment this out, and then you could have this as clang++. All right. And then now if you do make hello, it would use clang++ instead. All right. So that's the use of variables. Another thing I want to talk about is like a rule or a target called clean. So um, what is a clean target used for? So let's say you are, so I've come back to the terminal. Let's say you are actually uploading this code to um, like GitHub or some place like that. So typically, when you upload your code, you don't upload your upload your object files or your executable files because that could be system dependent, right? Like you're actually building this. I'm actually building this on my MacBook. If you're building this on a Linux machine, maybe the compiler has different variations and it has to like regenerate that. So you wouldn't want any of your object files or your executables to be part of your source code, all right? So typically, that means that you have to remove all of your object files and your executable file before you are like committing your code and Git or zipping your code or whatever. All right. So one way to do that is to do hello.o. So you're removing hello.o and your hello executable. Now, if you have multiple object files, you could use a wildcard operator like star, so which means like all object files. I need to remove all my object files. All right. So if I run this, um, it's gone now, right? Now this is a statement which I might be like repeatedly using, right? So it makes sense to have this like easily accessible. And this could be like a long line as well. If I had like if I'm building a huge project, I might have like multiple executable files. So it could be like a long list, and I don't want to be like constantly typing those every single time, right? So this is where the make clean comes in handy. So you copy that and then you paste it as a recipe here. Okay. So what this means is there is a target called clean, and if you do make clean, it's going to come here. It doesn't have any prerequisites because you haven't specified any prerequisites. It doesn't have any prerequisites, and it's going to run this. All right. So let's actually test this out. So I want to first create all of the files and then let's remove this. So let's do make hello first. And so it is creating all of the files here. And then now let's do make clean. So it ran this command. And then now, um, yeah, now all of those files have gone. Um, Okay, so this is one way to, or like this is why you would see a clean target in a lot of make files. Okay, so we covered variables, we covered clean. Okay, another thing, another like cool feature about the make utility is um, is how it actually keeps track of um, the timestamps between the different dependencies. So, for example, um, what was our dependency chain? So we had hello, which was dependent on hello.o, which was dependent on hello.cpp, right? Now, make internally knows that if so let's say you make hello. Now you have both hello.o and hello here. Okay. Now make knows that or it is keeping track of um, like if hello.cpp hasn't changed, then if you ask it to make hello again, it doesn't have to um, do that again because hello.cpp hasn't changed. So, like, if you take just this dependency, uh, if you ask make to or make utility to make hello.o, it'll check if hello.cpp has been modified. If it hasn't, then it's not going to regenerate hello.o. So let's look at this. So I just did a make hello, right? Now let's do a make hello again. Now it says make hello is up to date because it it came here. It checked if hello.o has changed. It hasn't changed, so then it doesn't have to run this recipe. And then it looked at hello.o, hello.cpp also hasn't changed, so yeah, it doesn't have to regenerate anything. Now internally, how this works is um, it uses or it checks the timestamps of the different files. So if you do ls-l, this lists like each of the files with some more details about that file. So if you look at hello.cpp, you can also see the the last modified time. And so hello.cpp was modified at 11:56, and then hello.o was generated at 1:12, and then hello was generated at 1:12 again. Now, if you ask it to make hello.o, uh, if the time of um, hello.o or like hello.cpp is newer than hello.o, that means that like hello.cpp has changed, right? So it's only when that happens that hello.o has to be regenerated. Okay, so let me give you a concrete example of this. Okay, so let's actually modify hello.cpp. So if we go to hello.cpp and we change this hello world to hello, okay, and then we run ls-l again, now we see that hello.cpp has indeed like its modified timestamp has changed, and it is newer or it is newer than hello.o. Okay. Now, if we run make hello, it'll first come to and check hello.o, and that target it'll check if hello.o is so it'll first check between these two. So hello and hello.o. Um, yeah. So let's look at this. So it actually finds that hello.cpp is newer than hello.o, and so it has to do this recipe again, and it builds that, and then it comes here hello.o is newer than hello, and so it does this. Okay, so does it make sense? So it keeps track of the timestamps, and then if it finds that some of these files have been modified, it does the step again. Now if we ask it to do it again, it says it is up to date. So it doesn't have to. So if you look at ls-l, hello.cpp, was used to create hello.o now. And so hello.o has a newer timestamp than hello.cpp. And then hello has a newer timestamp than hello.o. So this is how it keeps track of like whether or not to do a specific recipe or not. Yeah, I think that's everything that I wanted to cover for the basic hello, like sorry, the basic make tutorial. Thank you.